Hi everyone, this is Pierre Delos, and I'm going to talk briefly about our work towards governance of rule and policy-driven components in distributed systems that we're doing here at AGH in Krakow, Poland. So what we're trying to do is to render sets of policy or rule-driven components that are exposed over the network usable as one application. So for instance, in the Internet of Things, it's particularly relevant because so if you have different devices all over a city that manage traffic management or public transport or environment sensors, it's very difficult to make them work together because they are produced by different companies and use different technologies for policies. And for non-technical people to be presented this as one application to allow, for instance, buses to drive through traffic more easily can be great. Another use case we are working on is to do with telemedical devices, so elderly patients that are better suited to stay home rather than go to the hospital a couple of times a day or have a nurse go to their place a couple of times a day. They have personal medical devices and mobile devices to take measurements and receive advices from their doctors. And the system is connected through a cloud infrastructure to application provided to the doctor. And so the different personal medical devices make use of different rules. For instance, if the blood pressure is at a certain limit more than 3 times in a row, or if there is no blood pressure taken more than 3 hours in a row, then trigger an event or have the doctor do an action, and so on and so on. And we found out that, so for instance, in a typical scenario, you have at least 2 different types of rule and policies. So one to express actions for the patient, and one to gather events in the complex event processing engine. And if you want to be able to use different devices to connect to different doctor system and so on, it's an advantage to be able to connect them through a governance system. So we have additional use cases. So for instance, heterogeneous security federation, which is very specific because you have privacy and reliability issues. But to be able to connect enterprises, to connect their security system that are using different technologies as one system. Another use case is a cross-cloud application where each cloud is using different security, performance, and pricing policy technologies to be able to see that as one application. So different research challenges that we encounter in this situation are first discover the different components that are rule or policy driven, to make them interoperable, to be able to use them seamlessly in application, to interchange the logic, so if you have different types of rules or policies or expressions of facts, to be able to see that as one. And again, to see that as one, you need to be able to compile it in some sort of one knowledge base. So if you have 3 different rules written in 3 different languages that express the same thing, you want to present that as one, and to reason on this one instead of reasoning independently on the 3 different ones. And finally, usability with so many different systems, many different components that are using so many different technologies. It's a real challenge to make it easy to use for the end user. So what I'm going to present in the demo shortly is our demo software. So that is built upon these 4 layers. So the repository, on which I built the interpretation and the translation layers. So translation is to exchange the rules and policies and facts. Interoperation is to be able to communicate with the components. And I'm going to show the effects of correlation, briefly conflict detection, and combination. And what we are currently working on now is to improve the demo with the UI builder, abstraction management and validation, which I hope to present in a further video. So let's jump to the demo software. So this is a web interface that allows some level of governance of different policy or rule driven components that are distributed over the network. So during the demo, the data is cached in the database, but these are real components that are deployed over the network. And if I would like to, I could update everything by discovering and extracting content from the network, but this takes time. So we have two registries that are registered in the system at the moment. For instance, if I take this one, I can see that there are 4 components. So I can browse through the components. Okay. And see what is a component. So this component has three network interfaces. So management and functional, that allow interacting with the rule-driven component or the policy-driven component. So I won't go into much details, but basically we have some properties. So we know that this component is using joules as as business rule language. That it has this type of facts, so that gives us an idea about what the application, about what this component is doing. We know that at the moment there are these facts that are running inside the component, that they used to be these different facts. Alright. And that they are different rules, so we'll go into more details later. So I can browse all these different entities through this menu here. But what I'm gonna show here now is a summary of all the components we have in the system right now. So let's take for instance these two. So we see that this one is Jess, is using Jess rule language, and this one is using a Joules rule language. This one has 3. Well, they both have 3 rules, but this one doesn't have any active facts. This one, sorry, doesn't have any active facts, whereas this one has some active facts. And we can see that the rules are the same, although they are expressed in different languages. Okay, this is just to make they are the same because it's easier to demonstrate if it is the same. So for instance, if I want to show that they are actually written in different languages, so this is the Jess one. So if I want to show you that's a Jess rule, so we see rule base, rule, and on the other hand, if I show the Joules driven one, you can see, so 25, this is Joules rule. Alright, and the rules are basically saying the same, which is that on the left hand side there is a catalog item, customer, order item, order, and on the right hand side of the rule there is it's impacting on the offer fact type. So left hand side is if something happened on one of these fact types in the rule, then it has an impact on this. And if we want to see more detail on this, we need to check the rule itself that I just showed. So now I'm jumping to the governance, which is really what you want to see. So we have some translators, which are in our demo some XSL style sheets, which are allowing to translate the rules from one language, such as such as Reef PRD into another language, which is Jules ML, and so on. So I'm creating, so from all these components, I'm gonna create a new application, and so I'm just setting it up, and I'm picking, that's the two components I was showing before. So I put these two components into my application. I create the application, and here what it's done is that it went through all the fact types and the rules that are used in these components, and it's consolidated the facts. Okay, so at first here we have the same fact types. So if I go into the components and I checked, so for Jess, for instance, I check order, offer, customer, order item, catalog. So if I go into customer, I saw that this is a customer. Okay, so I can do the same for drawers to show you that these are the same indeed. So the customer is the same, and so these are put them together. So we know that in our application now that is using these two components, we have these facts and these rules, but these rules are now expressed in Reef because originally they're expressed in two different languages. So if I check the rule now, it's a different language that we are using in the application. So just to show you that we are indeed consolidating, I'm just going to, for instance, edit that fact type and say that a customer can have a name. So obviously, if you have running distributed components, you might want to think twice about changing anything on the component remotely, but this is possible. So here I've updated the fact type. Okay, so in the rules driven component, the fact type now looks like this, whereas in this one, in this one the customer still looks like this. But if I now refresh this, so just to show you, now in the consolidated fact, the customer now has a name, but the application knows that if you're playing with this fact in the application, if you're creating a customer with a name, this will only reflect on the rules fact. And of course, if you do changes in the rule, it will be the same. But this is more complex and would require more time to demonstrate. So I'm looking forward to demonstrate this to as many interested people as possible. If you would like a more complex demonstration with a combination of rules, please ask. Send me an email. There is my email at the presentation of the slides, right there. And it takes time to demonstrate, but it really shows the interest of trying to govern distributed adaptive components. Thank you very much for your time.